Okay, so today we are looking at 2.5, solving compound inequalities. We'll give you the definition first. Solving compound inequalities. A compound inequality is formed by joining two inequalities with the word and or the word or. A compound inequality is formed by joining two inequalities with the word and or. You are going to have two inequalities and we're going to put those together into a single inequality, and when we do that, it is called a compound inequality. Here's two inequalities. I have x is greater than or equal to 2, and I have x is less than 5. If I graph these on a number line, real easy number line, I'm just going to put the number 2 on here. This would be 1. This would be 3. If I'm graphing x is greater than or equal to 2, it would be a closed circle, and I would want my arrow pointing that way right there. I'm going to put this one out here. Same number line. I'm going to make this 1, this 2, this 3. Now I'm going to add 4, and I'm going to add 5. If I want x is less than 5, it would be this graph right here. And I can see right now, if I were to take these two and put them together, you would have an intersection of the graphs. When those intersect, these are called and statements. They look like this. They intersect. They go together. If I was to graph these on a single number line, it would look like this. I would have the number 2. I would have the number 5. This would be a closed circle going this way. This would be an open circle going this way. All I've simply done is taking my two inequalities, made a compound inequality by putting them together, and now I can see when I put these two together graphically, these graphs intersect. And I write that in a single inequality like this. You are concerned with the numbers or the x's that are between 2 and between 5. And I can see, if I look at this right here, I have x is greater than or equal to 2. That's what I have right here. X is greater than or equal to 2. On the left-hand side here, x is less than 5. That's what I have right here. This is how we see and statements. And if I look at them graphically, it is the intersection of them. it satisfies both of these inequalities. And the numbers that satisfy it, that are solutions to the inequality or satisfy the inequality, are numbers that lie in between these two numbers. If I choose a number between 2 and 5, let's say 3, and look at these inequalities separately, if x is 3 greater than or equal to 2? Yeah, it is. Is 3 less than 5? Yeah, it is. That's why the number 3, if it was right here, satisfies this inequality, because it is included in the intersection of these graphs. If I choose something like 6, is 6 less than 5? No. But it is greater than or equal to 2. Satisfies this part of it, but not this one. It has to satisfy both. We are concerned with the numbers that lie in between. The number 2, including 2, because it's a closed circle, everything up to the number 5. It can't be 5, it could be 4.999999, but it can't be 5. This is an and statement. Notice as well, my arrows are always pointing to the left, and my lower number is always going to be on the left. This is why I wanted us to start ordering these relations. Our number is going to be on the our low number is going to be on the left. I may have something that looks like this. Again, I have two inequalities, and I'm going to put them together. Here's my and. This, or these, are called or statements. I'm going to put these on a single number line because I want us to see what happens. I'm going to put -2 out here. I will put 1 right here, and I'm going to graph these independently. X is less than or equal to -2. Well, I'd have a closed circle at -2. I'm concerned with x's that are less than, which is to the left. I have that. X is greater than 1. Open circle at 1. Numbers bigger than 1. Everything there. Notice the difference in the graphs. Or statements go out. They go out. They go away from each other. I'm pointing out with my thumbs. That's an or. And is an intersection. We call this a union. This is two separate statements, and in order to satisfy the inequality, it only has to satisfy one of these. I write this by just combining the inequalities with the word or in between. Now I can pick some numbers. What if I pick 2? Is 2 greater than 1? Yes. But is 2 less than or equal to -2? No, it's not. 2 falls right here on the number line. It doesn't satisfy this one, but in order to satisfy this compound inequality, it has to be less than or equal to -2 or greater than 1. And the number 2 is certainly greater than 1. That is an or statement. Pick a number in the middle. What's between -2 and 1? Well, if I said 0, let's look at 0. 0, let's say it lies right there. Is 0 less than -2? No. Is it greater than 1? Is 0 greater than 1? No. That's why 0 is not included in numbers that satisfy those inequalities. That's an or statement. And intersection. Or is a union. Those go out. To satisfy an and, it has to be between these two numbers, satisfying the inequalities. For the union, or the or statement, it can satisfy one or the other. We're going to graph these. 0 is less than D is less than 10. When I look at that inequality there, it is joined together. There's a variable in the middle. This is an and statement, and I know that an and is going to be an intersection of two graphs. I am definitely not going to split those up and do those separately. I'm just going to do them now on a number line. Simple number line though. I'm going to say this is 0. I'll put 10 out here. They are both open circles, and this is an intersection. And I can look at these. I want D's that are greater than 0. That means I want D's that are this way. If I look at this inequality, D is less than 10. I want D's that are going this way. With an and statement, you will wind up with a barbell. You are concerned with numbers that are in between 0 and 10, not including 0 and 10, but any number between 0 and 10 would satisfy this inequality. Pick a number between 0 and 10. Let's pick 5. Is 5 greater than 0? Yeah. Is it less than 10? Yeah, so it should be included in there. What about 15? Is 15 that lies out here less than 10? No, it's outside of my values that satisfy the inequality. That's an and. A is less than -6, or A is greater than or equal to -3. Here's an or statement. And I know when I see that word or between them, I have a union. I have a graph that is going to go out. It's not going to intersect. It's going to go out. How do I know that? Because it says or. -6. Let's put -3 right here. These are the two values that I have to graph. Open circle, closed circle, because that's equal to A's greater than -3. That's to the right of -3. X is less than -6. Right there. Values that satisfy this inequality have to be less than -6, or they can be greater than or equal to -3. They have to satisfy one of them. It certainly is not going to be a number between -6 and 3. What's a number between -6 and -3? No, -5. Is -5 less than 6? No. Is -5 greater than or equal to -3? No, it's less than. That's why it's not included in the graphs. I have to flip my paper over, and now we are going to solve these. Solving compound inequalities. These are going to be just like solving equations. They're going to be just like section 2.4. We'll start off first with and statements. Intersections. Have something that maybe looks like this. Our goal is going to be to get this variable by itself in the middle. You absolutely have two inequalities here. You have x minus 2 is greater than -4, and you have x minus 2 is less than 3. Now you could certainly set these up, break them down, and solve two of them, and then come back together. And if I did that, if I was going to solve this, hopefully you would tell me I would add 2 here to -4. If I had this one, hopefully here you would tell me to add 2 to 3. We're going to do this in a single step. You're going to have to do it to all sides of the inequality. I will add 2 in the middle, on the end, and on the other end. Just going to simplify it. I'm lazy. I don't like to write those out twice. I'm just going to add it to all sides. And now I'm going to add down. -4 plus 2. -2 is less than x. That 2 goes away, is less than 5. This is ordered. My arrows are pointing to the left. My lowest number is on the left. I'm going to graph this, and I know that an and statement is going to be an intersection. Here's my number line. I'm going to say -2 is here, 5 is to the right of that. They are both open circles. This is an intersection. It better be the numbers in between. And if I look at this separately, x's that are greater than -2 is going to be this way. X's that are less than 5 is going to be this way. And I've got the intersection of the graphs, and it looks like it should because it's an and statement. These can get as complicated as we want to make them. I can give you distribution in here. You know, first we're just going to have to take what we know about equation solving, and when we're doing ands, the big key, get that x by itself, but you're going to have to do it to both sides of the inequality. Amp it up a little bit. This is -3 less than or equal to -2x is less than 9. Actually, I'm going to rewrite that. That's why I shouldn't use pen, but I know it shows up better on the videos. -3 is less than -2x. I'm going to add a +1 in there. Is less than 9. Now, if you had this one by itself, you would tell me, Mr. DeLong, you are going to subtract 1 and you are going to divide by -2. If I gave you this one, you would subtract 1, divide by -2. And hopefully you remember from section 2.3, when you divide by this -2, your signs will change, they will flip. We'll worry about that in a step or so.